Okay, the problem states, John drove his car 15 miles in the direction of 35 degrees south of east. How far south is John from his initial position? How far east is John from his initial position? So, he drove 15 miles, that's our magnitude, in the direction of 35 degrees south of east. So he's going south of east. That means he's going south from east. Okay, so when I draw my vector, I want to have a starting point, and I want to go south from east. So this would be the eastward direction. I'm just going to draw a dotted line here so I can remember where that is. And I want to go 35 degrees south from that. So I'm going in the south direction from east. And I need to go 35 degrees, so we're going to estimate it's probably going to look something like that. Okay? And this is 15 miles. And then we're going to label this side as we're going to label that angle as 35 degrees. And the question says, how far south is John from his initial position? How far east is John from his initial position? To find this, we're going to do something called vector resolution. So, I'm going to go ahead and label this eastward side in green, and that I'm going to label as X. Okay? Simply because it's usually the x-axis that is the horizontal axis, so I'm going to label that as the x side. And then the other side, my triangle that I'm creating here, I'm going to draw a dotted line. I'm going to label that as the y side, simply because, again, vertical, we usually use the y-axis. Okay? Notice I've just made a right triangle. And the two sides that are missing are the legs of a right triangle. Now, if we know two sides of a right triangle, we can always find the third using the Pythagorean theorem. However, in this case, we're missing both the x and the y sides. So we cannot use Pythagorean theorem. Instead, we'll need to use some trigonometry. So remember our trigonomic functions: sine, cosine, and tangent. And we remember SOHCAHTOA, little memory aid. Let's go ahead and figure out how far south John is from his initial position first, because it's the one it's asked for first. So south would be the y. So I'm looking for y. In order to use the trig functions, I have to remember which side is which. So I go to 35 degrees. In relation to this 35 degrees, y is the opposite side, x is the adjacent side, and 15 miles is opposite of the 90-degree angle, which makes it the hypotenuse. Might be nice just to label those so we can go ahead, look at our trig functions, find things pretty easily. So I want to find the opposite side, y. Okay, so I need one that has O in it. It's definitely not cosine. Okay, and then I need the other side needs to be one that I know. The one that I know is the hypotenuse. So I need an h. So this is the function that I will use for finding how far south he's gone. I start with the sine of the angle, which in this case is 35 degrees, is equal to the opposite, which I'm trying to find, y, over the hypotenuse, which I know is 15 miles. Okay, to solve this equation, I simply multiply both sides by 15 miles. Cancels out on the right side. On the left side, I am left with 8.60 miles. Next, let's figure out how far east John is from his initial position. So we are going to find x. Well, x is the adjacent side, so I need one that has an a in it, so it's not that one. It could be this one. It could be this one. Then I want to look at which side do I know. We just found the opposite, but what if we made a mistake? Or it's got some decimals. This is more of an exact answer, and we know it's correct because it was given to us. So I'm going to go ahead and look for one that has adjacent and hypotenuse, which just so happens to be the one that we crossed out for when we were doing the other part. So I'm going to use cosine. So the cosine of the angle, 35 degrees, is equal to the adjacent, in this case, that is what we don't know, x, over the hypotenuse, which is 15. Multiply both sides by 15. 15 times the cosine of 35 degrees is 12.3. 12.3 miles. So we know that John is 8.6 miles south of his original position and 12.3 miles east of his original position.